Hello, welcome back. In this lesson of algebra, we're going to be learning how to add polynomials together. Now, we actually touched on this a little bit in the last section because in the last section we introduced what is a polynomial, and specifically we talked about monomials, binomials, trinomials, and the generic polynomial. We also talked about degrees of polynomials in the last lesson. So if you haven't watched that, please go do that because we introduced a lot of the groundwork for what we're going to do here. Here we're going to be focused on this lesson and in the next one on how to add these polynomials together. And as I mentioned about 37 times in the last lesson, when you add polynomials or add anything in algebra, the only way you can actually add them is if you add the exact same variables. They have to have the same variable letter and they have to have the same exponent. It's the only way you can add them together. Even if it has two terms with x's in them, if one has a power of 2 and one's a power of 3 with different exponents, you can't add them because whenever you have the exponent defines what the object is, just like the letter. And in math, you can only add things if they're identical, like adding pencils to pencils. You can't really add pencils to dump trucks. I mean, you can, but it doesn't gonna make a lot of sense. So in math, they have to match exactly. So in order to jump into there and see how to do it, it's just much easier to do with examples. What if I had a polynomial, 5x minus 4? That's a polynomial. In fact, what kind of polynomial is this? You should know now that there's two terms, so this is called a binomial. Plus, the next one is 2x plus 3. All right, so that's another binomial. So we're adding a binomial to a binomial. Now I've wrapped them in parentheses because sometimes you see that, but also just to tell you that, hey, this is a polynomial, and this is a polynomial, and I'm adding them together. But in reality, since there's nothing outside of these guys to be distributed or multiplied in, then there's no real reason to have the parentheses there if I'm just going to add them. So even though I wrote it in the problem statement, you can drop the parentheses and just write 5x minus 4 plus all of this stuff, 2x plus 3. And as I mentioned in the last lesson, what you're really looking for is like terms. This is an x to the power of 1. This is an x to the power of 1. And because of that, I'm going to put a little dot under it to show myself that I've looked at these terms and I know that I can add them together. 5 plus 2 is 7. What am I adding? 7 x's. Because here's 5 x's, here's 2 more x's, and so when I put them together, I have 7 total x's. Now that's the only variables that we have, so here we have a negative 4 and a positive 3. You should know that negative 4 plus positive 3 is just negative 1. Then the negative 1 goes at the end. So when you write the answer, you'll write the powers of x in decreasing format. In this case, there's only one of them anyway. And then you have the minus 1 there. And that's the final answer, 7x minus 1. All right, so the next one, we're just going to mostly just crank through these guys. I'm going to have increasing difficulty as I go, very slowly increasing the complexity, but ultimately it's going to be the same thing every time. What if we have 5x minus 4? Now, instead of adding these polynomials, I'm going to subtract 2x plus 3. Now, you see the difference between this guy is that they're linked with, instead of addition, this is subtraction. So the only way I can proceed if I want to drop the parentheses, 5x minus 4, is this is a negative 1 on the outside. So this negative 1 needs to go in and multiply times this and then also times this. So negative 1 times the 2x is going to give you negative 2x. And the negative 1 times the 3 is going to give you a negative 3. Now I can add them. If you just drop the parentheses without distributing it, you won't have the proper signs everywhere and it won't work. So this is a negative 1, you have to distribute it in. Then I start looking for like terms. I have an x term here and I have an x term here. It's 5 minus, don't forget the minus sign, minus 2, which is 3. 3 what? 3 x terms. So that deals with the first part. And then I'm going to just, for clarity, I'm going to write the minus 4 here and I'm the minus 3 here. I'm not going to do that until the next step, just to make it absolutely clear. I have 3x. What's negative 4 minus 3 is negative 7. So it's 3x minus 7. That's the final answer. So you look for x terms that match, and then you look for the numbers that match, and pretty much we're going to be doing the same thing over and over again. No real difference. Let's take a look at the next one. It's going to look more complicated. T to the power of 2 minus 8 times t. Let's see here, minus 7, and then plus t squared plus 5 times t minus 6. Now, one thing I'm going to mention to you, I don't always do this, but I'm going to mention it to you. Notice that my plus sign is a straight up and down plus, but all of my t's have this little hook at the end. Hook, 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 hook. I guess you can probably guess why. If you just write your t's as little plus signs, then you're eventually going to get confused. When you have pluses everywhere, you're not going to know if it's the variable t or if it's a plus sign. So a long time ago, I got in the habit of hooking my t's at the bottom. So if I'm dealing with a variable t, I always write it like that. And I would encourage you to do that because eventually you'll have a large equation with plus signs and t's, and you can see how confusing it would be if you didn't make a distinction there. Now this is a plus sign, so yeah, you're distributing the positive 1 in, but it doesn't make any difference. So what I'll do next is I'll just drop the parentheses. T squared minus 8t minus 7 plus here, t squared plus 5t minus 6. And then I look for like terms. The largest power of t I have is the t squared here, and I look for other like terms. Here's another one. This is not a like term because it doesn't have a square. This is not a like term because it doesn't have a square. So I can add these. 1 plus 1 gives me 2. 2 what? 2 t squares. Here's a t square, here's a t square. You add them together and I get 2 of them. Then the next thing I'll do, I'll switch colors to make this a little clear, is I'm going to look for t terms. There's a t term, and then I keep going. Here's another t term. Obviously, I can't add it to the numbers because there's no t's there. But here I have negative 8, right here. Let me think about this. Maybe the best way to do it is to rewrite things. I'll rewrite it again. Let me go ahead and say this is going to be negative 8t minus the 7 plus the 5t. Minus 6. So all I've done here is I've added the t squares, and then everything else is just coming down. I haven't done anything yet. But now I look and say I have the negative 8 and I have the 5t. So what I'll do for that one is I'll say I have the 2t squared. That doesn't change. What is negative 8 plus positive 5? Negative 8 plus positive 5 is negative 3. Negative 3 times t. But I still have these numbers, and let me just carry them on for now. Minus 6. Negative 7 here, negative 6. I'm not going to do this forever, but here in the beginning I think I can do that. 2t squared minus 3 times t. What is negative 7 minus 6? It's going to give you negative 13, because 7 plus 6 is 13, and you have the negatives there. So you have 2t squared minus 3t minus 13. So again, I showed every step, just adding each term along the way. I'm not going to do that forever because eventually it's going to slow you down too much. I mean, I don't like skipping steps, but at the same time, I need to kind of show you how you're really going to do your homework. So in the first few problems, I'll break it out like this, but after a few times, we'll start kind of adding terms in parallel with one another, just to show you how you'll really do it. So we're on to the next page. Let's take a look at the next set of polynomials to add together. What if we have t squared minus 8t minus 7, we'll close that off as the first polynomial, minus t squared plus 5t minus 6. That's the second polynomial. Now notice critically that there's a minus sign. You're subtracting them. So the only way you can drop the parentheses if you distribute the negative 1 in, multiplying times every term. The first term is unaffected, so it's going to be t squared minus 8 times t minus 7. Negative 1 times this gives you negative t squared. Negative 1 times this gives you negative 5 times t. Negative 1 times negative 6 gives you a positive 6. Don't forget that positive because of the multiplication here. And then I'm going to start looking at what I can add together. I have a t squared term here. I keep going. I have another t squared term here. I don't have any other t squareds. So I have a positive 1 minus 1. So positive 1 plus a minus 1, or you can think of it as 1 minus 1. So really what's going to happen with these terms, it's going to give you 0. The t squares are going to disappear because it's 1 minus 1. So they're going to disappear, and just to have absolute clarity, I'm going to rewrite everything that's left over. This is left over. You're going to have negative 8t minus 7. The t squared's gone. Now we have minus 5t plus 6. So the t squareds are gone. That's all I've done. And now I look and see, here's a term with t, here's a term with t. What is negative 8 minus 5? Or think of it as negative 8 plus a negative 5. Then what you're going to get there is it's going to be a 13, negative 13 times t. Then I have the negative 7, then I have the positive 6. And then I can add those, negative 13. What is negative 7 plus 6? You're going to get negative 1. So negative 13 minus 1, negative 13t, I should say. Almost made a mistake there. So here's negative 13t, then you have this guy, which is going to give you minus 1. This is the final answer to the problem. So sometimes that happens. Sometimes variables disappear. If you have the same coefficient with different signs, it's going to drop away. And even though they are present in the original polynomials, when you add it all together and simplify it, this is going to not have the t squared terms at all. And I'll just take this time for a slight aside. This guy here, this negative 13t plus 1, mathematically is exactly the same thing as this big thing up here, because they're all equal as you go down, just like with fractions. 50 over 100 is the same as 1/2. They look different, but they're very much exactly the same thing. This large term subtracted with this large term is exactly the same thing as this. So when we say simplify, we mean get rid of all the terms and simplify and tidy up everything you can by combining like terms. Negative 13t minus 1. Now the next one, let's say we have 5x to the third minus 2x plus 1. And we're going to add that to x squared plus 2x minus 2. Let me just double check. 5x squared minus 2x plus 1, x squared plus 2x minus 2. Now, because it's just a plus 1 here, and you're going to distribute it in, but it's not going to actually do anything, so we can just write everything without the parentheses entirely. 5x cubed minus 2x plus 1. Then we'll just add the x squared plus the 2x minus the 2. And then we'll look for like terms. We look for the biggest value of the power of x first, x cubed, and we don't have any other x cubed anywhere else, so we'll just write the first term down as 5x cubed. Then we look for powers of x squared. We see we have an x squared here, but again, there's only one of them, and there's no other x squareds anywhere there. So again, we just write x squared down. So far I haven't had to actually do anything. Now I look at this. I have a negative 2x and a positive 2x. So when you actually add these two things together, negative 2 plus a positive 2, you're actually going to get 0. So I'll just kind of show you that by connecting these guys and putting a 0 to remind you that these add to give you 0. And then you're just going to look at the numbers. 1 minus 2. What is 1 minus 2? It's negative 1. So you can actually add this together. So the answer that you're going to get is 5x cubed plus x squared minus 1. That's the final answer. So we drop the parentheses. We can't add anything to this, so it comes down. We can't add anything to this, so it comes down. We try to add these, but it gives us 0, so it drops away. And then 1 minus 2 gives us the negative 1. And this is in decreasing powers of x. And again, as a bonus question, what type of polynomial is this? It's got 1, 2, 3 terms, so we call it a trinomial. And what is the degree of this polynomial? Well, the degree of this term is 0. The degree of this term is 2. The degree of this term is 3. So the degree of the whole thing is 3, the largest degree of everything listed. All right. Now, let's do the next one. We only have a few more of these guys, but they're all really, really important. What if we have, notice what we're going to do here is I've taken these and added them together, and the next problem we're going to take these two polynomials and just subtract them. So that's the only difference between these problems. 5x cubed minus 2x plus 1, close it off, open the next one, x squared plus 2x minus 2. This problem is exactly the same as the previous, except now I have a minus sign there, which means that I need to distribute the negative 1 in so I can add things together. So I have 5x cubed minus 2x plus 1. Negative 1 times this is negative x squared. Negative 1 times this is negative 2x. Negative 1 times this is positive 2. And then I start looking for things to add together. Again, 5x cubed, there are no other x cubed terms, so 5x cubed comes along for the ride. Then I look for x squareds. Here's an x squared, but there's no other x squared terms anywhere, so I carry it along as negative x squared, right? Then I look at x terms. Here's a term, negative 2, negative 2. I add them together, negative 2 plus negative 2 is negative 4 times x. And just for clarity, I'll drag the 1 down here, and I'll drag the 2 down here, but I'll add those in the next step, even though it's kind of simple. I don't really have to do that. 5x cubed minus x squared minus 4x, and then this becomes a plus 3. Let me double check. 5x cubed minus x squared minus 4x plus 3. So this is the final answer, correct. The only thing you have, and this problem is exactly the same as the previous one, it's just one was added and one was subtracted. It made all the difference in the world because when they were added together, that caused these terms to kill each other and basically annihilate and give you 0. And that didn't happen here, and that's why we have more terms. This is a polynomial, again, of degree 3, the highest degree of all the terms that are present. I only have 2 more problems, one that we will do on this board and one that we will do on the next one. So what if we have 5 times y cubed minus 2 times y plus 1, and we'll add that to y squared plus 2y minus 2. Let me just double check it's correct. 5y cubed minus 2y plus 1, and then y squared plus 2y minus 2. It's a plus sign, so I'm distributing a 1 in. It's not going to change anything, so I'll just rewrite it. 5y cubed minus 2y plus 1 plus y squared plus 2y minus 2. And then I start looking for things to add. Here's my largest power of y cubed. I don't have any other y cubes, so I'll just say 5y cubed is my first term. Then I'll look for y squareds. Here's one. I don't have any other y squareds anywhere, so the next term I don't have to really add it to anything. It's going to be y squared. Then, again, I have a y term here, and I look around and I have another y term here, and it looks like the same thing happens. I have a negative 2, and I have a positive 2. Just coincidence with the last problem, but they add to 0, so nothing happens. And then 1 minus 2, I'll go ahead and write it like this, plus 1 minus 2. So I'll have the plus 1 here, the minus 2 here. The y's kill each other and divide and basically give you 0. So what I have is 5 times y cubed plus y squared. What is 1 minus 2? It's negative 1. That's the final answer, 5y cubed plus y squared minus 1. Now in the final problem, we will take these exact same polynomials, but we'll have a minus sign in there. So we'll be subtracting the same polynomials instead of adding them. All right, so let's take a look. What if we have 5y cubed minus 2y plus 1, and we'll be subtracting the next term, or the next polynomial, trinomial, y squared plus 2y minus 2. And we're going to subtract them, which means we have to distribute this negative 1 in. So let's go ahead and do that. 5y cubed minus 2y plus 1. What is negative 1 times this? It's going to give you negative y squared. What is negative 1 times this? It would be negative 2y. Negative 1 times negative 2 will give you positive 2. So that's going to give you that. And then we'll switch over and say, look for like terms. Here's a y cubed. We don't have any more of those. So we'll have 5y cubed. We have y squared here. We don't have any other of those. So we'll have negative y squared. Then we look at y terms. Here's a y term. Here's a y term. But now it's negative 2 minus another 2. So negative 2 plus a negative 2. So you get negative 4y. Negative 2 plus a negative 2 gives you negative 4. And then you have the plus 1 from here and the plus 2 from here. So the final answer will be 5y cubed minus y squared minus 4y and then plus 3. 5y cubed minus y squared minus 4y plus 3. And notice that this is different than before. We only had 3 terms in the previous because of the way it all worked out, we actually had a cancellation, which means we add to 0, so those y terms drop away. There are no terms just in y. But when we changed it to subtraction, they ended up adding together, giving us, or subtracting, however you want to think about it, to give you negative 4y. So, goes without saying, polynomials are really important. And adding polynomials is really important because you're going to find out that lots and lots of problems in real science and math, you might have one function over here that's a polynomial, and you might have another function over here that's a different polynomial, but to find the answer to the whole thing you're trying to do, you might have to add them together. So that's why we're spending all of this time adding them. Make sure you can do every single one of these problems and get the correct answer, and then follow me on to the next lesson. We'll continue adding polynomials. It's slightly increasing the complexity as we go, but ultimately we'll be doing exactly what we've been doing here for slightly more complex problems.